Alright, I know I went through this quickly the other day, so I want to go over it again slowly with you guys, so this way you could catch up, no problems. What we're going to learn today is section 5.6, the rational zeros, how to find them. What I want you to copy down in your notes from page 370, the key concept, the rational zero theorem. If you're given a function f of x with the integer coefficients, make sure they're integer coefficients, then every rational zero of f has the following form. Remember, zero means it's a solution of the function. So every rational zero of the function will be of the following form: p over q, where p stands for all the factors of the constant term. Remember, the constant term is a term without the x there. The q stands for the factors of all the leading coefficient, all the factors of the leading coefficients. Okay, so you can set up this ratio for all these factors. Okay, so let's take a look at example 1a. All right, we're given a function f of x is equal to x to the third plus 2x squared minus 11x plus 12. Okay, the directions tell us to list the possible rational zeros of f using the rational zero theorem. Again, the rational zero theorem tells you to set up this ratio, p over q, factors of constant term over the factors of the leading coefficient. So, constant term is 12, let's list the factors of 12. Well, we can start with the easiest one, then go to 2, 3, 4, 6, and 12. Now, because it's a positive number, we could do plus or minus for all of them. Remember, if we multiply two negatives together, we get a positive. So if you did negative 6 times negative 2, that is equal to 12. Therefore, negative 6 and negative 2 are factors of 12. And factors of 1, very simply, are just plus or minus 1. Okay, so now let's set up our ratio of p over q. We want all the factors of the constant term, factors of 12, over the factors of 1. So, starting to list, we have 1 over 1, and this is all plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, plus or minus 12 over 1. Okay, simplify it, you get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and then plus or minus 12. And that is how you find all possible rational zeros. Now, you had work to do in the textbook, hopefully you understand. If not, now you can go back and work on that. But let's see where this comes actually into play. All right, skip to example 2 on page 371. Okay, directions say is to find all real zeros of the following function. F of x is equal to x to the third minus 8x squared plus 11x plus 20. Okay, first, step 1, we want to list all possible rational zeros. Remember, we want p over q, p being the factors of the constant term over the factors of the leading coefficient. So, simply, our leading coefficient is just 1, so everything's going to be over 1. So I'm going to go a little quicker here. Let me list the factors of 20, because that's my constant term. And factors of 20, again, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and then plus or minus 20. So there's all my factors of my constant term. Again, they're all going to be over plus or minus 1. So here's our list of all the possible rational zeros. Okay? So now, second, we want to test these zeros using synthetic division in order to find which one is a real zero. Okay? So, let's start off with positive 1. Okay, again, synthetic division. Let's set it up. Negative 8, 11, 20. Okay, drop the 1 first. 1 times 1 is 1. Negative 7, 4, and we get 24. This shows that 1 is not a zero. Now let's try another one. How about negative 1? Okay, we set that up. 1, negative 8, 11, 20. Drop down the 1. 1 times negative 1 is negative 1. So on and so forth. Aha! Now negative 1 is a 0. So, we know that's a 0. Okay? So now we can write the function as x plus 1 times x squared minus 9x plus 20, using our synthetic division from over here. Okay? We could factor this out more in order to find all of our real zeros. And if you're terrible at factoring, like some people are, that's okay. Use the quadratic formula. X plus 1 times x minus 4 times x minus 5. Okay, so now all the real zeros are negative 1, 4, and 5. Got it? Good. Try the guided practice. Three and 4. And go back and see if you could finish all the problems that were on page 374. Numbers 3 through 18. If you finish them already, try working on problems 24 through 35.